and move it up and down, then this one on the right and the one on the left are still the same curves, right? So it's my choice now if I want to go type 1 or type 2. I'm going to do type 2 because we haven't done a type 2. So let me treat it as a type 2. If I'm going to do type 2, I'm going to treat that like a type 2. I need to find my constant bounds on y, then the bounds on x, and then the bounds on z will come from over here. So what would my restrictions on the y be? Between two constants, right? 0 and 1. So that's set, right? And now I need restrictions on x, and those should be two functions of y, right? So I'm going to look at this right here as a function of y, and I'm going to look at this over here as a function of y. I think we call them in the notes h1 of y and h2 of y. So what are they? What's this one over here? 0, because that's just constant 0 function. And then this one over here, this comes from this line, right? Which is, just by inspection, y is x. That's y is x. Again, we don't have a plane. Never mind, we can't do it. I was thinking something else. So I need to solve this for x. So this is y, isn't it? Yes.
Never mind.
Sure.
Yeah. Doesn't matter what. So when we're doing the left and right functions, when we're saying which one on the left, which one on the right, is it kind of the same as Cal 2 when we're looking at it? We go, oh, approaching from the right. This is first, and this is last.
I don't know. In Cal 2, how did you look at it?
Well, when we're doing like y bounds, we're doing like right to left, then we're doing expounded top to bottom.
Top to bottom. Okay, right to left. So you're saying it depends on how you want to look at it. Yes. If you're saying this way, you're going top and bottom, and then you're saying when you're going this way, it's right and left. And if that's the way you know it, yes, stick with that.
Okay.
Yes. The way I look at it is by just turning my head to the side. And I'm just saying this is the bottom, that's the top now. So this is the lower one, that's the upper one.
Right.
So I would say left to right, because I always start with the smaller and go to the bigger. But okay. I don't want to confuse you. Stick with what you know. All right. What do we have still left to do? Because I've got my restriction on x, right? It goes from 0 to y. I need to know what the top of that thing is in the bottom. Any of those you know quickly? Z0, the bottom one, right? So this bottom piece in here is u1 of xy is 0. But I need the top piece, this piece. It's a plane. But I didn't give you the equation. But I gave you points. How do you find the equation of a plane if someone gives you points? Well, that was from way back when, right? Chapter 10. So how do we get the equation of this plane right here? You need a point on the plane and a normal vector, right? How do you get the normal vector? Cross product of two vectors that live on the plane. So you got to make sure you get two vectors now that live on the plane. So let's identify some points on this plane. The origin is here, right? This point right here, 0, 1, 1, right? And this point right here, which is 1, 1, 0. You cannot accidentally grab this one. If you grab that one doesn't live on the plane, then it's all over after that. So it's these 3 points, right? Live on the plane. And now I'm going to create some vectors. Doesn't matter, as long as they live on the plane. I'm going to take the vector that goes from here to here. I'll call that vector u1. And then here to here, I'll call that u2. I know you might be sitting there going, don't use u. We're already using u1 and u2. Those are vectors. They are not scalars. So I could have used something else, v, whatever. So the normal vector will be u1 crossed with u2, which for us would be, what is u1? Aren't they nice? Aren't these vectors nice? Because when you go subtract, it's just those two, right, written as vectors. So I have to take the cross product. Remember how to do that, right? You do, I like to write them vertically, like this, and that way I can do the little, remember this thing? Okay, keep it going. The cross product will equal the normal, which is, so how do we get the I component of the vector? Cover up I, determinant of this, so 1 minus, so 1. And then cover up the middle and flip the sign. So negative 1 and what?
Oh, gotcha.
Here, minus here. Okay. Then cover up this one. So 1. That's it. 1, negative 1, 1. We need a normal vector. We need a point on the plane. Do we have a point on the plane? Let's go with 0, 0, 0. It's the nicest one, right? So the equation I'm using, if you've forgotten because it's been so long, remember that equation? That's the equation of a plane if you know its normal vector and you know a point on the plane. So it's just going to be 1 times x minus 0, so that's just x. And then negative 1 times y minus 0, so that's just minus y. And then c, which is 1, times z minus 0, so this is going to be plus z equals 0. Now just solve for z. Questions? Solve this for z. Negative x plus y. That is the equation of this top surface. u2 of x, y is negative x plus y. Whew. All right. Set it all up now. I should probably fill this out. This is negative x plus y. So I think hopefully you see that really the challenge of this is just getting the integral set up, right? It's getting all this information put together, get your integral set up. After that, it's just integration, right? Triple, 0 to 1, 0 to y, 0 to negative x plus y. I'm integrating xz, d what? Z d x dy. So you have to be careful with that, right? Because your outer are your restrictions on y. And that tells us right there it was a type 2. That switch there. Okay, so I'll offer right now 2-point bonus on your next test, which is the final. Volunteer, raise your hand. Give me the triple integral as a type 1. If we did type 2, you have about 5 seconds to raise your hand. Go ahead.
Okay, is it 0 to what?
0 to the first one? No. 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 Okay. No. Nope. That's it. That's too much time. Okay. 0 to 1 here. 0 to x, 0 to negative x plus y. Everything else the same except dz, dy, dx. That's if you had left it as a type 1 instead of type 2. The only difference in it is we went this way, right? So x is between 0, 1. Y is between, oh shit, no, hold on. Y is between x and 1. X and 1. That's why it's so important to draw it, okay? Because the switches are not as simple as, do y'all see that? The bottom one is x, y equals x. The top one is y is 1, constant all the time. So everyone gets the extra. No. All right. What's next? What's next? Everything we've done was a solid with the shadow cast on the xy plane. Why did we do it on the xy plane? No one told us I mean, no one says it has to be that way, right? What if you have, whoa, what the hell? Oh, what if you have this situation? Actually, let me put the solid in here so you can see what I'm talking about. Look at this solid right here. Why can't I do that the way that I have been doing things? Yeah, like look, its shadow is a, if you look at its shadow, you are not going to be able to see a type 1 or type 2 region. Because what happens is as you go up on the sides, try and turn this just a little bit. If I were to try and look at that shadow on the ground, you see this curvature here? I would only pick up that outer edge of the shadow. But there's a lot of things happening in here with my x and y values. They're changing. And so that won't work. I could not do that as a type, or like the ones we've been doing. But if this particular object has a nice shadow going up against the YZ plane, then maybe I can do it. So I could have my y stuck between two constants, my z's stuck between two functions of y, and then I could have my x's be surfaces. Holy shit, right? So you have this case, and then you could have this on the wall be a type 2 region, right? The other way around. And then you could also have a shadow on this wall in two other possibilities. And we aren't going to go through all these. We're going to stick mostly to what we just did. But we want to make sure we understand that you could actually have a solid where your shadow down is no good and you have to look at other ways. All right? I believe I say that here. No, I make you do it both ways. All right. Let's skip that one. Okay, here we go. This looks like a fun one. Evaluate the triple integral of z dv where your solid is bounded by blah, blah, blah. All right, let's give you about 10, 15 minutes, see what you can do. All right?